All right, hello everybody. I'm glad you've all navigated your way here successfully. My name is Brian Gardner. I am an Android developer for Cash App, and I want to talk to you all about maps. So recently in Cash, we've had some features come out which required us to display maps to the user. In one case, we enable people to deposit money into their Cash App account through physical businesses like 7-Eleven and Walgreens. But we also wanted to enable them to withdraw money from an ATM with their cash card. While doing the ATM version, I noticed that, hey, there's a composable now for Google Maps. If you've had experience with the map view before, like me, you probably know it's not super great to work with. Generally just kind of unpleasant in a lot of cases. So I was very happy that there's a composable now. Hello, there we go. So this is kind of a view of what the feature looks like. You basically can search for a particular location, and you can see, like, hey, here's where I searched, and here are the ATMs that are available. So this involves kind of setting up the map, giving it a location to display, defining where some of the markers are, and so forth. We also wanted to enable clustering, so when the user zooms out to a certain level, we don't want to have like a ton of markers on there, because that's just not a great user experience. So we want to make that a little bit better. So first thing, you're going to need some dependencies, as with all Android things. Basically, there's two things. There's a Compose Maps library. Version 2.11.4 is the latest one. You're also going to need Play Services Maps. You kind of can't get away from that one. So you'll add those, add them into your project. Oh, one thing I'll note, these dependencies are technically incorrect. They're all supposed to be on one line, but for slide purposes, that it just looks a little bit better. Last thing you'll need is an API key. You can get that for free. Go on there, sign up, and you just get a developer token. Now, when you're setting up the map, there's basically three essential pieces of information. The first one is you're going to tell the map how it needs to render, basically like how do you want it to look, the general theming, what landmarks and stuff do you want to stand out. The second is all about user interaction, so what sort of gestures do you want to support, what sort of built-in UI elements do you want to be there, and the last one is what location do you want to display. This one isn't technically required, but if you don't supply this, it loads the lat long 00, which is right off the coast of Africa, and there's no ATMs there. So first things first, map rendering. So this one, we use a map properties object. It's fairly straightforward. There's a lot of stuff in here, like, do you want the 3D buildings enabled that Google Maps supports? Some buildings apparently have indoor like representations. I didn't know this was a thing, but it's in there. Is my location enabled? This one is the one you got to look out for. If you try to set this to true, your app must have either coarse or precise location permissions, otherwise it will crash your app. And this one will basically show a location dot on the map wherever the user's location is. You can say, hey, do I want traffic enabled? You can set the bounds for the camera. Basically, you give it like a northwest point and a southeast point, and that's kind of the bounding box for the camera that loads. You can also provide map style options, which is basically a way to theme your map. The map type, so this is normal map, which is kind of what you see if you open up the Google Map app. You can also get like the satellite map, the terrain map, the hybrid map, stuff like that. And last but not least is your min and max zoom preferences, basically just how far the user can zoom in and out. Now, most of these are set to false or null by default. So in our case, we wanted to set the style if we're in night mode. So we tie into the is system in dark theme in this case and say, hey, load this resource file for us. Otherwise, we're just going to use the default style, so we provide null there. Now, for the night mode style raw resource, this is a JSON file, which has, it's huge, honestly. This is just a small snippet. Basically, it says, hey, for these particular map features, style it in this way, color it in this way, or don't display it. Fortunately, you don't have to create this yourself. There's a mapstyle.withgoogle.com. You basically go in and say, like, yes, I want these features. No, I don't want these features. And it'll just spit the JSON out for you. Makes it super easy. Once you have all of this set, we can create our map properties. Now, since we want this to be fast, we're going to remember this. We key it off of this has location permission field. This is just like a custom field that my presenter is sending down, depending on if we have location permission or not. And then we're just going to remember our map properties. Once we have the properties, then we need to define how we want the user to interact with our map. That is done using a map UI settings object. This basically says, like, hey, do you want the built-in compass to show up? Do you want the indoor level picker enabled for the buildings that support the indoor level stuff? Do you want the map toolbar? Now, if you see this and you think, oh, toolbar, like the thing on the top of the screen that people, like apps use, that's not what this is. I was very confused. Basically what this does is this shows a little rectangular view with an icon that will open Google Maps. So it'll take them from your app to Google Maps. I don't know why they called it toolbar, so you can probably just turn that off. They have a built-in My Location button if you want to enable that. Our designers were quite insistent that they wanted a custom one, so we turned that off. And then there's a bunch of things about gestures, like what gestures are important for your particular use case. Like, do you want them to be able to rotate the map with 2 fingers? Do you want them to be able to scroll around the map? You can determine if scroll gestures are enabled during rotation or zoom. They're getting very specific here. Things like tilt gestures, zoom controls, which are the little plus minus icons that display in the bottom right of the screen, and the zoom gestures. Now, unlike the map properties, all the map UI settings are enabled by default. So in our case, we didn't want most of these, so we just turned all of them off. Again, I'm going to remember it here, so we're not recreating this object on every recomposition. Last but not least is we need a location to display. Now, there's a special remember call here, remember camera position state. This basically will remember a camera position. So this one comes from the Maps Compose library, the remember camera position state, and then you need to set the position property inside of that remember call. Basically, you give it a latitude, longitude, and a zoom level, and that will basically center the camera on that location at that particular zoom. Once all that's ready, you throw it into your Google Map composable, give it a modifier, camera state, map properties, map UI settings, run the app, and we got a map. At this point, the user can move it around however your map UI settings are enabled with the scrolls and zooms and everything. And it just kind of works, and it works pretty well. There are a couple things we'll need after this, one of which is updating the location. So in our use case, we basically had a search that user could search for a particular location to update the map. So we basically need to be able to tell the map that, hey, we have a new location, please move it to this new area. So the way we did that, this is basically all the code we needed. The location here is just a custom object that had latitude, longitude, zoom, and a couple other things, like a token to identify this particular place. But we say, hey, throw it in a launched effect because we only want to do this every time the location changes. And then we can basically tell our camera state to move to a new place. It requires a camera update factory that can generate us a new camera position. And we use the same from lat long zoom as before. So anytime our presenter or view model or what have you sends a new location to the view, it will animate over to that new location. Now, being able to have your presenter tell the view where to go is great, but we also need to be able to react to the new locations as the user pans around. So in our particular use case, as the user scrolls around their city, in my case, Savannah, I want to be able to say, hey, when the camera is idle, give me that new position, let me query on our back end for the new ATM locations, and then display all of those on the screen. So with your camera state, there's an isMoving property that you can key off of. Again, we'll put it in a launched effect, so it only fires when this actually changes. And we say, hey, if we're not moving, then we can notify our presenter that we're kind of idle in that case. It might look something like this. You say, hey, we have an event. On camera position changed, and then you can reach through your camera state to get things like the latitude and the longitude, as well as the zoom level. Maybe you're going to use the zoom to kind of figure out how big of a radius do I need to search for, and things like that. Now, once we actually have the location, we need to display the markers on the screen, because having a map is cool and all, but if a user can't find what they're looking for, it's not super useful. Now, we can use the marker composable in order to display things on the screen. The key thing here is the state. So your marker needs a state. You're going to give it a key. In this case, I just have a token for a particular location, just a unique identifier. And then you give it a latitude and a longitude. So say, hey, make me a marker, put it at this position. That's really it. You run your app, you get your beautiful default Google Map marker. Now on the previous slide, if you're wondering what the title property was for, if you click on the marker, it pops up a little info window. It just displays your title on there. And you might be wondering, hey, what if I need to change how this info marker looks, or how this info window looks? There's a marker info window composable. Very similar to the regular marker. You've got your state up at the top, exactly the same as the regular marker. But it basically has another composable function parameter, and this will be the content for your info window. So in this case, I just have a couple text fields inside of a column thrown on a surface, and it shows up. Now, another thing is, most apps probably are not going to be okay with the default Google Map marker icon. They're going to want to style it in some way, so you're going to want that to be custom. This one is a little odd, I'll say, just because the Google Maps doesn't operate on like a drawable or a resource ID or anything like that. It requires you to create a bitmap descriptor, which as far as I can tell is only really used in this maps area. So walking through this, we load our resources from our local context. We are going to remember our bitmap descriptor because, again, we're loading resources and we don't want to do this on every recomposition. We'll use the resources compat to get our drawable. In this case, my icon marker is just a default vector asset I added through Android Studio, and I'll just immediately convert that over to a bitmap object. And then I can pass that over to the bitmap descriptor factory to get me my bitmap descriptor. And then once I have that, I can actually pass it to my marker as my icon. And when I run the app, I have my tiny little Android on there. So relatively straightforward. I do wish that they would have used just like an icon asset or something as opposed to bitmap descriptors, but it works. It's okay. But this icon is not great for accessibility, so I'm just going to go back to the old markers for the rest of the talk. If you want to display multiple markers, fortunately with Compose, this is super easy. You just iterate over whatever locations you want to display as a marker, create a new marker composable for each one, and it just kind of works. It's great. You might be thinking, hey, this is cool, let me just add all of the markers in there, and it's not great. So in these kinds of cases where you have like a ton of markers, this is where clustering comes into play. Basically, we want to say, okay, these markers are in a general vicinity of each other, so we want to group them together and display basically a number that says, all right, there's 5 markers here, and when the user zooms in, it'll actually break it out for you. So clusters. There's a couple ways that you can handle this. One is you can use the Android Maps utils library. This is kind of the standard with the framework map view. The problem with this, though, with the Compose version is you need an actual reference to the Google Map object. So what they've done is there's a map effect that you can use inside of the Google Map composable, and when the map is ready, you can get a reference to it and then set up all of your clustering that way. Or clustering is now supported in the Maps Compose util library, so it's another dependency you have to add, and it is experimental at this point, but you can do it all in Compose now. Now at Cache, we went with the first option. Why, might you ask? Well, because they hadn't made the clustering util yet, so we were kind of stuck with that. I'm currently in progress of updating to the other one. And I am here to say, please don't use map effect. It's a pain. It's not great to set up just because there's a lot of asynchronous things going on and things have to be set up in the right order at the right times. Basically, when you want to display a cluster, you would have to create a cluster manager, which would handle, like, it knows how to display a cluster, it knows how to display a single item. But using this in Compose land was not great because if you used a cluster manager, if you also tried to use a marker composable, the cluster manager intercepts all of the touch events. So your marker will no longer react to any kind of touch events, and that's not great. So basically everything has to go through the cluster manager. Also, if you wanted to have multiple different kinds of markers, you'd have to create a cluster manager for each different kind of marker and then combine all of them into one single marker manager, and it's not great. Please don't do that. What we can do instead is use the Map Compose utils library, same version as the Maps Compose library. And just a couple things you got to do first. First off, you need to create a cluster item object. This effectively represents sort of like a marker in the cluster world. So an individual item, when it's fully broken out, is a cluster item. When it's all grouped together, then it becomes a cluster. So for your cluster item, there's basically three things you got to override. It's just an interface. You got to specify your position, a title, and a snippet. Title and snippet are optional. Those basically pop up in the info window for you if you just want it to look like the default, but you can just provide null there if you want to handle that yourself. And then there's a clustering composable. So once you take whatever your location objects are, map them over to your new cluster item, you just pass those right into the clustering, and we go from this lovely sea of red to some clusters. And as you zoom in and out, it's going to constantly kind of re-evaluate what things should be clustered and what shouldn't. So as you zoom in, you'll see specific items break out that are too far away. And as you zoom back out, they'll kind of regroup together. Now again, most people are probably not going to want to use the default UI, so if you do want to provide your own custom UI, there's two composable lambdas that you can invoke, one of which is the cluster content. This one is the one that displays like the number of items at that particular point. So you get a cluster parameter. This gives you basically the position of that cluster. It gives you the list of cluster items that are represented by that item, as well as the size of that list. So you can just declare your own custom composable that displays at that point. For a single item, there's a cluster item content composable that just gives you your cluster item class, so you can display whatever you need to for that single item. Now, in my case, I was like, cool, it's a single item. I'm just going to use the like custom marker composable that I had created before and pass it in here. That doesn't actually work. If you try to do that, you get a illegal state exception, something about an invalid applier going on. Basically, you can't use a marker composable from within the cluster composable. You just kind of have to do a custom thing there. So just a kind of a way you can shoot yourself in the foot. Last but not least is cluster UI events. Now, we want to know when a specific cluster is tapped, as well as when an individual item is tapped to handle that differently. For the on cluster clicked, there's a lambda for that. Gives you the cluster, same thing as for the cluster content. So you can do things based on the specific lat long, based on the collection as well. So what that might look like, say, hey, fire an event. Our cluster's been clicked at this latitude and longitude with these particular items. So maybe you want to center the map on that and zoom in a little bit so it'll kind of break out the cluster a little bit more. That's what we did in our case. Or maybe you want to take them to like a detail screen to show all of the items at that particular spot so they can pick a specific one. It's really up to your use case. For the individual items, there's an on cluster item clicked function there as well. So you can get your individual cluster item and then handle that as you need to. So in this case, you might say, hey, when they click on one specific item, I want to take them to a detail screen about that specific location. So you can say, hey, this item has been clicked with this particular token, and then your presenter can go off and do whatever navigation you need to. One thing before I almost forget, these functions return a Boolean value. This basically tells the system whether or not it should pass the click event to the Google Map composable as well. If you return true, that means that you have handled the click event and it doesn't need to pass it through. If you return false, that means it's going to pass it to the map. The default behavior when the user taps on the map is it just centers that particular location. All right, so key things, don't use map effect. It is not worth it, please. The clustering behavior is great. Definitely recommend that. And just make sure you're remembering all of your things, your map properties, your UI setup and everything, just to kind of help speed things up. Now, as we were going through this, we did run into some issues, and some that we are still facing at this point. One of which is with paparazzi testing. Now, if you are not sure what paparazzi is, the quick explanation is that it enables you to create a view on the JVM and take a snapshot of it. So you don't need an emulator or a physical device running. It kind of all happens. It uses the same technology that Android Studio uses to display the previews inside of Studio. So it's really quick, it's fairly easy to set up, and it doesn't work with the map. So we were originally running into some weird errors about like, oh, your API key hasn't been set up for this app, which was weird because it was in our manifest and it was working on device. So we were digging through that, trying to like mock it out in our tests and everything, and then it was complaining about like Google Play services not being available and whatnot. And eventually we were just so fed up with it, we were like, okay, we don't really want to snapshot the map. We have a bunch of other UI elements displayed on top of the map. We want to test those. And the map was working inside of preview. Well, working is a strong word. It basically showed a blank box, but it allowed us to actually see the rest of our UI. Digging into the Google Maps composable, we found out why. Very near the top of the function, it says, hey, if this local inspection mode flag is on, return a box. So basically, when Studio is running your composables inside of the preview, it's going to set this local inspection mode flag, and it's just going to display a blank box. So that's what we did too. Inside of our tests, when we use the map, we basically also provide the local inspection mode flag. So it's not the best because I would still like to snapshot the map with markers and things on it, but until that is somehow supported, at least we have kind of the rest of our custom UI snapshotted as well. One other big issue that we had was performance. So we're building out the app, we're playing around with it, like kind of testing it on our phones and everything, and we noticed that the performance is pretty bad. So much so that in some of our builds, like the screen would freeze for several seconds, just lock up, not do anything. And that was kind of concerning. Now, with Compose, the debug build performance can have issues because there's a lot of stuff going on in the background with debug builds, with like the live literal updates and everything that Studio tries to do. So a good thing to check is how your release build performance is. And our release builds were better, but there were definitely cases where it would like stutter and freeze as well. Not to the same degree, but definitely like we did not want to ship it at that quality. So doing some digging, one thing that you can do is you can specify the map renderer that you want to use. Now this is something that you can also do with the framework map view, but I think it's just a little bit more apparent the benefits that you get in the Compose version. So what that looks like is you need to call the map renderer or map initializer and say, hey, please initialize with the latest renderer. So it takes context object just because it's doing some stuff in the background. It basically calls through to your Google Play services to get the renderer, and then the lambda that's passed is basically a success or failure lambda. So whenever it's done, it'll pass it back. In our case, we didn't care about the results, so we just ignored it. Now, one important thing to know about this initialize function is that you have to call this before you do any kind of setup with the Google Map. So if you initialize your map and then you try to initialize the renderer, it's not going to work. Because as soon as the renderer is started, trying to call initialize is effectively a no-op. It's going to be like, hey, you're already using the legacy renderer. We're not going to do anything now. So typically, you're going to put this code in something that runs on app startup. It can be called on the main thread. It can also be called on a background thread. It doesn't really matter. Funky thing number 2 about this is that even when you call initialize with the latest renderer, the first time the user loads the map, it's not guaranteed to use the latest renderer. Now, the reason for that is when you specify you want the latest renderer, Play Services needs to download the renderer. It's not something that exists inside of Play Services by default. They actually have to go download it from Google servers. And that can take time depending on what sort of network you have access to. So there is a chance where you say, hey, give me the latest renderer. It starts downloading, and then you immediately open your map. If the download hasn't finished, it's just going to default back to the legacy renderer. So that first time, you'll get the legacy one, but when you leave the app and come back, as long as the download is finished, then you'll get the latest one, and it'll be there the rest of the time for your app. One more issue with this one. So we got the map out, launched the feature. We're like, great, this is cool. And then we start getting some exceptions. Some users were running into ANRs when we were setting the latest renderer. Now, this wasn't ideal, I'll say that, but it wasn't also terrible because it was kind of like a one-to-one situation. A user would basically hit it once, and then the next time they started the app, it was fine. So doing some digging on the Google issue board is this issue basically saying, hey, we're seeing some ANRs with this. I dumped, I don't know, like a dozen different stack traces on there trying to get them to work on it, and fortunately they did. So in the version of Play Services that went out in early May, I think it was like version 24.11.4 or something, there is a fix for this. But because it's a fix in Play Services, there's nothing we can do in our app to fix it. So we basically have to wait for people to get Play Services updated on their device, and then we'll see that trend start to go down. We have seen it start to actually decrease, but again, as long as users don't have that latest version, we're still going to see some of those ANRs, which is unfortunate, but the performance benefits we get out of the map itself more than make up for that. All right. Well, thank y'all for coming. I appreciate it, letting me kind of chat at you about maps this whole time. Again, my name is Brian Gardner, work for Cash App. You can find me on Mastodon if you're on there. I'm not on there a lot, to be fair, but I am going to post the slides, and I have like a little sample project that covers a lot of this stuff. So if you're interested, check it out.